Hello everyone. In this project, I have simulated an energy system of an apartment in Proteus, and this system communicates with a graphical user interface which is written in .NET. First of all, let's take a closer look at the Proteus simulation first. Here we have 3 Arduinos, 2 subsystems, 3 debug consoles, and a COM port to communicate with the interface. Here, this subsystem represents the blocks of the apartment, and in these blocks there are 4 devices. These devices are simulated with resistors whose values are changing. For example, this device 1 has 1 ohm resistor. With the help of the relay, these resistors can be driven. If we give enough voltage to the relay, this relay will be switched on and the current will start flow through this resistor. And let's talk about the input and the output for this subsystem. Here, E1_VR represents the given voltage to the device. Here, D represents the control signal for this device, and E1_VO represents the voltage of the device. Everything is the same for the other devices. Now let's talk about the inputs and outputs of the block subsystem. Here, dV is the given voltage to the block, and in Proteus simulation this value is 5 volts, and we have control signals for each device which comes from the Arduino itself, and we are using I2C communication protocol between Arduinos. With the help of the logic state, the I2C address of the microcontroller will be assigned. Everything is the same for this block and its controller too, except the slave addresses. And here it is their master. This microcontroller is responsible for the controlling of the block microcontrollers, and this microcontroller will be called as Apartment microcontroller. And this microcontroller communicates with the graphical user interface. I mentioned earlier that this system uses I2C communication. These microcontrollers are the slave microcontrollers, and this one is the master one. So that is it for this Proteus simulation. Before getting into the graphical user interface, I want to mention about the debug consoles. Before doing that, we must run the simulation first. When I started the simulation, 3 console windows appeared as expected. The first console window shows the current powers of devices in block number 1. On the second console window, current powers of devices in block number 2 are shown. Now you can ask the question that how can you calculate the power? So we know that these dV values are 5 volts, and we know the resistor values of the devices. So V squared times R gives the power of this device. So that is the formula I have used to calculate the power. But it is not possible to control these devices on Proteus now. I have designed a graphical user interface to do this job. So we can switch to the graphical user interface part. Now here is our graphical user interface. As you can see, the graphical user interface is split into 2 parts. The first part is the control part, while the second part is the plotting part. Now, let's take a closer look at the control part of the graphical user interface. As you can see, there are two group boxes, and in each group box there are 4 checkboxes, a text box, and a button. With the help of the checkboxes, we can on-off control the devices, and using the text box we can override the total energy of the device. For example, we can override this value are 10,000. Before getting the real simulation, I want to show the on-off control with the help of checkboxes very quickly. To do that, we need to go to block 1 and the device 1 to observe our relays switch. And I am going to start the simulation and our program and close all the blocks. Now, as you can see from our first terminal, the power values for all devices are 0. I did not mention earlier, but the first column stands for the device 1, the second column is for device 2, device 3, device 4, and the summation of the columns. So, I am going to open the device 1 and you can observe the movement of the switch. Power value is going to be 25 and the power curve of the block 1 will increase. As you can see, our relay switched on and our power value is 25, as you can see from the power curve or the block terminal. Our total energy limit is 10,000 and our spent energy is increasing. The integral of the power gives us the total energy spent. So, with the help of the integral, I can calculate the spent energy. And if the block 1 reaches its limit, all devices is going to be shut down. Let's see this by overriding the total energy limit to this value and open these devices. As you can see, our curves increased and we have reached our limit and our devices are shut down, as you can see from the block terminal. That was a simple simulation of on-off control of device 1. Now let's consider a little bit more complicated one. For this scenario, let's consider that block 2 has 5,000 energy. So let's start the simulation and our program. So you can see all the power values of the blocks. When block 1 reaches its limit, its devices are going to be shut down, as you can see. The power values are 0, but the block 2 has energy, so block 1 can transfer energy from block 2. So let's do this. Who offers this transfer? Block 1. Which block's energy is going to be transferred? Block 2. How much energy? Let's transfer 1,000. So energy transfer is successful and the devices on block 1 is running again. Let's consider another situation that block 1 has reached its limit and block 2 has reached his limit too. When this situation occurs, the only thing that they can do is buy energy. So let's do this. Who buys energy? Block 1. how much energy is going to be bought. Let's buy 500. The energy is bought. So block 2 can transfer energy from block 1. The amount is going to be 100. But as you can see, block 1 has already reached his limit, so he has no energy to transfer. But the block 2 wants this energy. This transfer is going to be failed because there is no energy left for transfer, as you can see from the label. The only thing they can do is buy energy again. Block 1 buys 10,000 and block 2 buys 10,000 too. So the devices are on again. You can on off control the devices. As you can see, the power values are changing. And while I change the values, I change the states of the devices, the curve is changing too. Let's increase again. Increased. Let's increase a little bit more. It's increased. So let's close this to 1 and close this one. And shut all the devices, and we will reach 0. And everything is the same for this power curve too. The values are changing there too. That is it for my Proteus project. Thanks for watching.